Hello and welcome to the DIF. Welcome back to the DIF. Welcome to the third day of our 5-day event, the Ellen MacArthur Foundation's interactive online event series that aims to shift mindsets and inspire action towards a circular economy by sharing disruptive ideas, disruptive stories from around the world. And that is exactly what we're doing this morning. My name is Seb, and I'm super happy and proud to be your facilitator and host today. It means I get to ask the questions to my guest who has done something that a little bit unusual, and that also means that I have the pleasure of asking your questions and putting your comments to my guest today. And there's a few ways in which you can share those with me. If you pop them in the comments section on the right-hand side of the thinkdiff.co website stream, if you're watching it there, you can put them in the YouTube comment space. And you can also tweet us using hashtag ThinkDiff, and my colleague Clemence will be gathering those and post them through, and I'll put those to our guests as we progress. So today we're talking, or this morning we're talking about plastics. The problems and challenges with plastics are quite well advertised. The Foundation's own research has highlighted that only 14% of plastic packaging is collected for recycling. Just 2% of that is recycled to the same quality material. And of course, one of the third is leaking into our oceans. But the question is, what can be done about it? And for certain formats and applications of plastics, there's growing belief that actually new kinds of material or new kinds of plastic alternatives could be a powerful option, especially biodegradable or compostable plastics. And that's sort of what we're talking about today. I'm joined by a guest who is working on one such innovation. In fact, they've created something called Lactips, which is essentially plastic packaging made out of milk. It's a great pleasure to be joined by Marie-Hélène. Hi, Marie. Packaging made out of milk, how is that possible?
Well, a few years ago, my co-founder, Frédéric, started a research on how to do a thermoplastic from natural proteins. This led him to put a patent on thermoplastic made of milk protein. So that was the beginning of our story together. We met in 2014, and we set up that company.
Where do you get an idea like that? The idea of like, how do the idea to that let's look at proteins and how can we turn those into material? Because when I think milk or any kind of protein, actually, I don't think packaging.
Well, we had quite similar background. So he was a researcher, I was a plastic engineer, and we didn't know each other at this time. But we decided not to be a plastic engineer anymore in 2004, and him to work. Don't put his talent in doing synthesis, but in more working on natural polymers, how influence the future. So he has foresight that that there was a need for a change, and so I became an entrepreneur, and I set up a company about photovoltaics, so changing completely my mindset. And he started his research. He influenced his research on natural polymers. And the research of this that is wonderful, that they search and they find things maybe unexpected. So he found out how to make a thermoplastic from milk casein, and it was a discovery.
So your background is actually in plastics. So you were working. So obviously you were exposed very much to the challenges with that material. And was that the motivating factor for getting into this?
Yeah, I participated to the pollution actually. So yes, I worked for the automotive industry for several years. So the question was what I wanted to do with the rest of my life, and yeah, I decided to change the kind of impact I could have on my environment.
So there's milk. We turn some milk protein into plastic packaging through some kind of clever scientific process. Do you want to just say what kind of process is that? Is that at all similar to regular plastics production? Is it comparable to anything that our audience might be more familiar with?
It's not synthesis. It's the cow that make the synthesis of a protein. Huh? So this is a natural process at the beginning. So we buy the protein that has been made by nature, and we use a very common technology on plastic industry. We use a twin screw extruder to make a thermoplastic out of it. But we've got a lot of know-how. It's what we do is a simplex. It seems simple, but is a complex technology because make it a thermoplastic means that it can be used by all the industry of plastics. And so you can make, for instance, I've got here samples, so rolls of films, or you can
So
do.
is that you're just showing us there? Is that sort of like cling film?
Yes, it's a film that is completely natural, biodegradable. It's made out of pellets, so we sell pellets today. It's completely. It's well. We've been making design thinking over our material. We wanted to do something that was without impact on the environment. So we worked a lot on our formulation so that the formulation of this plastic is without chemistry. It's 100% natural. It's so at the beginning of the life. So this design thinking, we selected only ingredients that has no impact in the end of life. And we design applications through the supply chain because we are plastic specialists, and we wanted to propose new solutions for packaging, for instance, or for single-use plastic that doesn't have an impact on the end of life. So we have been thinking application and formulation so that we don't have any impact on the environment. So that's because plastic has become a big problem for us all. That we at Lactips wanted to develop and industrialize and sell plastic that are plastic free and that has no impact on the environment. And we did it through our strong IP, our strong research, and our strong know-how to do it.
And so what we're getting at there a little bit as well, so you mentioned replacing single-use plastics in particular. Are there some applications that, well, I guess there's a two-part question. One is, have you been targeting, so is this material more suitable for certain applications? And two, we've seen the film. What are some of the examples of the applications that are already made out of those pellets that you create?
Yes, so the quality of this material is 100% biosourced, fully biodegradable, whatever the environment, whereas it's water, seawater, soil, whatever, because we work with the natural polymer that already exists in nature. It's a water-soluble material. So first thing that we replaced was the PVA. That's what is around your dishwasher tabs, for instance. So is this kind of application, so for dishwashers. And we go forth, and if you want, I've got some visual for you to see it more clearly, what are the application and where we work. Would you like that?
Do share that with us, yes.
Yeah, okay. Then I'll share. Maybe I share first the environment of plastics. Huh? So I just for sharing environment of plastic and make you better understand what is it about. So you've got I don't know if you see my dot. First column is non-biodegradable and fossil and fuel plastics. There and then in the range of the impact on the environment for us, industrial compost plastic, and then home compost plastic, it's better suited. Soil compost plastic, it's better. Water biodegradable plastic, and then marine biodegradable plastic. I think that the ultimate goal is to be marine biodegradable. And you see that our range of Lactips is playing in natural polymer fields and bio-based field. So with this area of application, we can help partially biodegradable, partially bio-based plastic to be more bio-based or more biodegradable. So if I share, and maybe I go to applications for you to better understand what we are doing, and I try to share again for application. So that what I told you that our first application were on replacing PVA for detergent industry, and we go forth with liquid detergent to help liquid detergent not to use this PVA. So if we go, you see that there are a lot of scent boosters that are used also for detergent industry. Mainly, first of all, our first step was detergent industry. Because there is a lot of plastic use in detergent industry we are not aware of, and those scent boosters, those pellets, were part of it. So we designed 100% bio-based, biodegradable pellets for the scent boosters. And maybe I go to the blend. So our material is a very gas barrier, quite good, because we are at a level of the gas barrier that is used today on your food packaging. So we can increase biodegradability, we can increase bio-based content, and we can increase oxygen barrier on a lot of plastics that are very fitted with ours, that are PBAT, PBS, PHA. Maybe I speak a bit of Chinese, telling all those names, but people from plastic industry, those are the new bioplastic. That is the new generation of bioplastic, and sometimes they are not completely fitted. So we can increase biodegradability of those plastics, making them disappear from environment earlier, or we can increase bio-based content so that there is more bio-based in these blends with other plastics. And above all, we increase oxygen barrier, meaning that now the new plastics, they can be used for food industry if they are blended with our material. So then you don't see our material alone, you see it with other plastics. And this is very important for food industry and for packaging.
So just to clarify that point, you're able to sell your plastics to people who are also blending them into other bioplastics.
Yes.
What does the temperature requirement on this slide here? It says a temperature requirement 130 degrees Celsius, which is pretty hot. What does that refer to?
Yes, because you know that the fossil-based plastic have got a temperature of transformation that is around 200 degrees. But the protein transformation temperature is less than 130 degrees. So this is one requirement for us, and all the biopolyester that are the bioplastic that are coming on the market, they've got temperature that are okay for blending with our product. So this is a big move for plastic industry. And sorry, you heard that? I hope not. It's a big move for plastic industry because we are going to make them have less impact and increase their properties as a oxygen barrier that is very important for food industry. So this is a big move for packaging. And if we look at the design thinking that we are been doing on improving recyclability on complex packaging, the problem today with complex packaging is that they are not biodegradable, non-recyclable, and some of this is leaking to the ocean. So we worked a lot on giving functional barrier, oxygen barrier, fat barrier, mineral oil barrier. Instead of going on with those complex packaging to dissociate the function. So I'm going to unshare and show you an example, and then I'm going back to this. Well, so you see this is a pack of chocolate. So it's our plastic around. It's a plastic-free plastic. It's 100% bio-based. Is fully biodegradable. It's gas barrier. It's a mineral oil barrier. It's fat barrier. It's a chocolate inside, but it could be a biscuit. It could be a powder of anything. So what does that change on for packaging industry? So the change, and now I share.
One of the things I was just going to say about that example is that it's exactly the kind of application and function that is very hard to capture in today's system because it's so small format, and therefore there's a lot of value in that packaging, which is not always going to be easy to collect in recycling systems. It's not going to be necessarily easy, something becomes wasted. That sachet being biodegradable is extremely valuable for the market. I kind of have a question about biodegradability because it comes up a lot. There's a bit of confusion. Obviously, it's a huge, positive aspect to this product. It's something that you're emphasizing. There's a lot of confusion about what biodegradability actually means for different things, and it can mean a lot of different things in different products. So for some products, and they're either biodegradable or compostable, but only in certain circumstances. Some products are actually bio-based, but actually not biodegradable, for example. Is that a challenge? Well, two questions. One, can you clarify exactly what you mean when you say Lactips is the plastic is biodegradable? Does that mean chuck it on the ground, chuck it in the ocean, it won't affect anything? And two, is that a challenge for you in terms of communicating your product, that there is this kind of blurred confusion about what it actually means?
Yes, there is a lot of confusion about what biodegradation means. First of all, we talk a lot of biodegradation, and it is also confused with recyclable. And so what we say is recyclable is good because you take energy from the planet doing plastics. If there is no leakage and everything is recyclable, and then you take back this energy to fill the system again. So we think that recyclability is a perfect way if there is no leakage. So means that you need a recycle system. So a system, a supply chain that is installed to recycle it. So as you said, for small parts, it's not when you sort out the plastic, it's not done. Then this one is burned. And this is a loss of energy from the planet, because we burn it and we do something with it that is heat, that is valuable, but also gas that is not valuable for the planet. And the heat is less valuable than a return in the cycle of life of the plastic. If I make myself understand, I think it's a difficult notion to think about. Then the plastic, from my point of view, should be recycled the more possible. But if it's not recycled, then that's what you guys that you did really well, making studies about what is ending up in the ocean. So a lot of plastic shouldn't be made of fossil and need to be biodegradable. So then what does that mean, biodegradable? Biodegradable means a lot of things. Can be biodegradable in soil. If a plastic ends up in the soil, it's important that is biodegradable in this environment. If it ends up in the ocean, it needs to be biodegradable in seawater. So this different category of biodegradation, in my point of view, should be taken in account by application, so that there is a possibility that we have the less possible impact on the environment. Did I answer your question?
Yes, thank you. There's actually a question from the audience from Matthew, which I think picks up on the other side of the chain when it comes to questions about bioplastics. So, for example, there's concern with some bioplastics that they actually require a lot of land to grow the crops that become the feedstock for that. His question is, what's the source for the plastic production, and are there is there enough of it, I guess, and what are the impacts of that?
Yeah, talking about the resources, very important. So how do we create a natural thing that has going to be no impact on the upstream supply chain and the downstream supply chain? So we've been talking on the downstream supply chain, no impact in the environment and the end of life. What about the beginning of our life? So we've been working a lot on our resource, so the casein. Casein is from milk, so
because presumably we're not talking about, sorry to interrupt, but we're not talking about milking cows and you turning that milk directly into plastics, as maybe that's worth clarifying for Matthew.
So what is the question from Matthew?
I think for him the question is where is it coming from, the product that you're using to create Lactips, and how finite is that supply, and how challenging are there going to be challenges down the road in terms of scaling that supply?
So we are using casein from the milk. And so what we've been studying is the balance on the production of milk is it's a very unbalanced production, because you need more fat than you need unskim milk. The fat is used 100%, and there is a remaining of unskim milk, and our protein is coming from this unskim milk. So it's a surplus of production. Also, we use milk casein that cannot be used for food industry. For instance, the limit of consumption has been passed, or the producer of milk protein make mistake in its production and he cannot sell it for food. So we don't use the feedstock, and there is a surplus of this protein. So we've been very careful on creating a system that is sustainable. that we are not going to grow more cows to produce our product. And there is sufficient resource of milk that is unfit for human consumption to make a plastic out of it, something that has no impact on the beginning, on the upstream starting of life, and no impact on the end of life. And that was very important for us.
So presumably you had to make relationships then with farmers or big holders of milk from somewhere. Is that true?
Yes, so we make contact with casein producers. So this industry is an old industry that is set already. It's so we buy directly the casein from the producer of casein. We don't go to the producers of milk, of the people that exploit the cows. We buy it from an industry that is already settled all around the world.
And I kind of had a broader question, actually, when we talk about industries. What's been the reaction from the plastics industry to what you're doing? Are they scared of you? Are they excited? Are you working? Are you likely to work? I mean, do you work for any large traditional plastic manufacturers or brands? What's the sort of, as you go out with this idea and you begin to, turn it into functions, what's the kind of reaction been from some of the big players?
Well, at the beginning, they were curious, but we had more scouting than a real will to put it in production. But that was 5 years ago. The big changes in this market was regulation, consumer awareness. So the consumer started thinking that it didn't want to participate anymore in the ocean pollution, and the brand commitment, and with you guys, Hélène MacArthur played a big role in this change of mindset. Now we've got proposals for packaging industry. Maybe I can show you an example about how this kind of thing is very useful. And now we've got a customer that they want directly to put in the market very quickly. So it doesn't go through scouting, and then it goes directly to industry. Also because our product has been improved during those last 5 years. So that's also the life of a development. So we've got a product that is ready to making films. And formerly we were improving quality, improving. Now we are ready. So the change of way of thinking it from the industry is a big change, and it has changed this last 2 years. And there is a lot of pressure from them to have this product to put in the market to fulfill their commitment of 100% recyclable plastics or packaging, and this kind of commitment they made, and regulation. So we fulfill all regulation because so it's so biodegradable and so natural. So that
you're saying actually there's a sort of demand now emerging for Lactips, that in many ways your people are coming to you, or at least looking for solutions like you. Did you say there was something else you wanted to share around the sachet example?
Yes. So if I may share what we propose for the complex film, because this is a problem for packaging. So let's try. So today when you've got the packaging, you've got this. You've got secondary packaging that is a multi-layer with inside. So it's a vapor barrier, but it's also an oxygen barrier. Inside, you've got the same thing. And this system makes big pieces of plastic, but also a lot of small pieces of plastic that are non-recyclable, non-biodegradable, nothing. And then our proposal is a design synced proposal through supply chain, is to use a secondary packaging that is vapor barrier, that is necessary for the food that is inside, but to use our plastic has a primary packaging that is oxygen barrier, like the small pieces of chocolate that I show you. So that this system is recyclable or home compost. Our product is home compost in that case, or soil compost. That's a first proposal for packaging industry to
Does this have any impact on? So if the packaging is 50% recyclable and 50% compostable, is that not a problem for actually being compostable, actually being recyclable? Do you see what I mean? When I hear, at least the way I'm interpreting that a little bit is, does that mean that not all of the packaging is therefore recyclable? Sorry, not all of the packaging is compostable, and therefore it won't actually compost? Or, you know, how does that actually work? How do you separate those two? If you're mixing the materials, do they have an impact, and are they? How do you separate them?
Yes, for instance, you've got a box, the blue one, the blue layer that is a barrier to vapor, to water, and you've got small pieces of chocolate inside that box with our plastic inside. You see that you don't consume the same way the packaging that is outside from the inside. And when you open our packaging, you can you eat the inside, whereas you trash it in any one of your bins, whereas it's the recycle bin or the compost bin or the bin that is burned, our plastic is going to disappear without impact on either of the system. So with the washing on the recycle system, our plastic is going to disappear. If you put it in your bin for compost, it's going to be composted and eaten by the.
So I think I understand now that, you know, a box of Celebrations or Quality Street or Roses, the box itself is going to be recyclable. It's one type of packaging, but within those boxes, of course, you get individual sweets wrapped up. That packaging is actually not normally recyclable as it is right now, and is obviously very small and not easy to collect into recycling systems, even if it was. So in some ways, it'd be nice if that could just be chucked in your compost bin, or, you know, at least you know that if it escapes or isn't recycled, that it's not going to be harmful and it's going to biodegrade eventually. Sorry, yes, that makes much more sense.
Yes. And the other subject we have been working on, and another proposal from us, is the paper lamination. So you see the brown layer is paper, the gray layer is our film. So in paper industry, when you coat it with fossil material, fossil film, then you've got paper that should be recyclable, and you make it non-recyclable because it's coated with plastic that is non-recyclable. And so we were thinking about how we can do it recyclable again. So complexing, laminating, coating with our own polymer, that the behavior of our plastic, even if it's plastic free, is the one of a plastic, can be sealed. So you can seal it, and it's an oxygen barrier, it's a fat barrier, it's a mineral oil barrier. That is very important for paper industry, because if the paper is recycled, then you need a mineral oil barrier. And then you've got a system that is, again, recyclable or home compostable, and the end of life is easy.
This makes a lot of sense. We are actually just about running out of time, unfortunately. I think there's sort of one big question that we haven't tackled, which I'd like to put to you before we leave. And it's come up in a couple of audience questions, and I think it's almost an obvious question for our kind of audience to be thinking about, because actually the way you presented those two kind of solutions just now, there's a sort of logic to it that's sort of neat, and it seems so simple. And you know, I guess the question is, like, why is this not happening everywhere? And so I wondered, what are the big kind of challenges for you? Are they around how do you then scale the production of this? What's on the horizon, and how do when will we start seeing a lot more Lactips in the market, in your view?
Yes, so today we've got one first line of production. So capacity is 1,500 tons per year. For plastic industry is a small capacity. And the challenge is we are putting a plant end of 2020. This plant will be ready with another line of production, and it's the speed. Our challenge is the speed in which we can implement number of line of production to fill this market. I think that we will have more demand when the years in the coming years, because regulation is putting pressure on putting new products on the market.
I mean, for viewers, do you guys have any sense of time scale? Like, in 5 years' time, would you expect to, Lactips to be in so many products or to have such a volume, or is it actually in the case of where the project is and where the work is a bit shorter term? How do you get to the next? How do you get the next big partnership or whatever? What sort of mindset have you guys got in terms of that scaling piece?
Yes, in 5 years, we will have completed this first plant. I think that we will be thinking of another plant. I hope. So the way we work is as I told you, so we do strong partnership with our customers. And maybe is an old-fashioned way, but I believe in trust and in partnership. So that's what we do. We build a strong partnership and we work with this partnership.
Brilliant. Thank you so much for joining us this morning, Marie-Hélène, and thanks for sharing the story of Lactips. And I hope that you at home have been a little bit inspired by this. Of course, you can go online to find out more, and we'll post some stuff on the page. There's information on the thinkdiff.co page. There's information about Lactips if you want to find out more about the work. And we certainly will be looking forward to tracking the story as it progresses. This is the morning of day 3 of the DIF. There's lots more to catch up on and watch. All these sessions are available to watch straight away, almost straight away afterwards. So do check out thinkdiff.co and the foundation, Ellen MacArthur Foundation's YouTube channel. Up next at 11 o'clock, we're looking at something completely different: the power of data and information and how city citizens can take advantage of that. If you're really interested in plastics, if you haven't got enough of plastics, then at 2 o'clock, we're looking at another topic on plastics, which is plastic credits, a scheme kind of inspired by carbon offset. So tune in at 2 o'clock GMT for that. But thank you so much for joining us today. Thank you so much for our audience for your questions and comments. And thank you so much again to Marie-Hélène for taking the time out of, I'm sure, your very busy schedule to talk to us. And we hope to see you again very soon on the